Okay, so in this video we are looking at the Raspberry Pi's GPIO, and that is this bank here of 26 pins. Now what this allows us to do with this GPIO is connect up some hardware. GPIO stands for General Purpose Input Output, and what that means is we can send a signal into the device via, say, a switch for example, or we can send a signal out of the system via a set of LEDs. So with a little bit of electronics and a little bit of code running on the Raspberry Pi, we're able to interact from basically our computer system to a physical hardware electronic system. And hopefully in these following examples we'll show you how you can achieve some very cool things.
Okay, so the first example here is where we're just going to get its output LEDs and blink. So we enable all three LEDs, they turn off in sequence, and then after that's been done it will go through and blink them on off, on off, on off, and continue to do that until we cancel the code. Second example is where we use physical input switches to turn an LED on and off, but that is done purely through Python code. Okay, so these are the components that you're going to need to buy. You're going to need to buy a breadboard, it's the first thing. This is quite a small breadboard. You need a big bag of LEDs. You're going to need two push-to-make switches, non-locking, so meaning when you press the button and then release it will not stay on. You're going to need some jumper wires, and they need to be male to female. What that means is that the male part is going to be this little bit here that's going to go into the breadboard, and then the female part is going to be the bit that's going to go onto the Raspberry Pi header. Going to need some resistors, so I've bought quite a few here, but all you're going to need for this example is three 270 ohm resistors. You're going to need two 10 kilo ohm resistors. You're going to need some black and red single core wire just for a bit of wiring, and this is what your final result will look something like. Obviously we can see how it's connected to the Raspberry Pi GPIO headers and how we connect this up to our breadboard. So here is a closer view of it, and this is a layout that hopefully you'll be able to work to. And here's a schematic which I stole from this website here, so there's the link if you want to look at it. Okay, so let's learn a little bit about our GPIO pins, our headers. We have 26 in total. They number left to right, sort of inner to outer of the board, 1, 2, 3, 4, 5, 6, all the way down to 26. We have different functions for different pins, so they're not all exactly the same. In total, there's probably sort of around 7 different sort of functions. The first type of function we have is a power source. So we have a 3.3 volt and a 5 volt. We also have a 0 volt, which is our ground, so obviously to make an electronic circuit. We have our DNCs are mapped here, which are do not connect, meaning that they're reserved and are not currently functional, so they'll do nothing, don't connect them. We then have our GPIOs, which are a very simple on-off switch, essentially. They can handle a high signal or a low signal. At the moment, the two programming languages are only able to handle that at the moment. They're not able to handle the other type of connections. The other type of connectors we have are the IC2s, which are here, and which is an IC2 bus. We have a UART connection, which is here and here. And we have a transmit and a receive. That's for a RS232 serial cable. And then we have a serial peripheral bus, which I'm not going to go into too much details, but these are located here. Now, you're probably wondering why I've got this laid out twice on this spreadsheet. I have it laid out twice because the way that they're numbered on the physical aspect is different to how the Broadcom chip, which is the main heart of the Raspberry Pi, actually interprets that. An example of that would be if we ever wanted to activate GPIO 0 to turn on the signal, or we pressed a button and we want to talk to GPIO 0, the software would actually recognize that as GPIO 17. Now, it's a bit of an illogical link between the different components, but I don't see it changing anytime soon, and I think that it's just something you have to learn. So this spreadsheet will be available to anybody who downloads my package, and Obviously from here you'll be able to link this up and use this reference once you're building your circuitry up. Okay, so the standard Debian image that you get at the moment doesn't come with inbuilt software to be able to talk directly to the GPIO. So what you're going to need to do is download basically an interpreter or a library that will allow you to do so. So the first thing we're going to do is we're going to change into the directory home/pi, and in there I'm going to make a directory called GPIO where we'll download and we'll store the libraries that we can install. Okay, so let's move into this directory here. Right, this is empty. So what we need to do is to get one of these interpreters. The first one we could look at is quick to wire GPIO, which I believe is written in C. And if I'm wrong, I'm sure people will tell me. But the one we're going to be using is a Python library. So I'll put links in this to this in the directory. So what you need to do is come to this site and download the Raspberry Pi GPIO. It's still in beta, so 0.2 TGZ file. Okay, so download that to your PC. Okay, so I'm going to use WinSCP to log into my Raspberry Pi, and then from here what I'll do is I'll go to my download sections. Okay, so I'll come to my Pi, I'll back up and go to var, and I'm going to drop this in temp, and then I'm just going to drop it in there. Come back up to my Raspberry Pi. If I say sudo move/var/temp GPIO to my current location, and if we look now, we have those files there. Okay, so it's in a tar.gz file, so we have to run the following commands: sudo tar -zxvf, and then give it the file name, and that will extract our files. So we can now move into the directory it's created. Okay, so they've nicely created a installation file for it as here called Python setup.py. So we run sudo python setup.py install. Okay, so it's going to install that wizard, and job done. That's what it'll look like once it's finished. Okay, so in the bundle of information I provide in that link, you'll get two different bits of Python code. First one is going to be called blink.py, which is the first example, and this is what the code looks like. And then the second example we have here is I call it inout.py, so basically you put an input and you get an output. Okay, so what we want to do is transfer those onto our Raspberry Pi. Okay, so again with WinSCP, we can take these two scripts and transfer them over to our temp directory. Okay, so what I'm going to do is I'm going to move into a directory I've got here, which is /home/pi/scripts, and then what I'm going to do is I'm going to say sudo move/var/temp, and I'm then going to move blink.py to blink.py here, and then I'm also going to move inout.py to inout.py, and then in here we have our two extra scripts. So if we want to execute these commands, we can run sudo python blink.py. Okay, so the other example that we use is when we run this one. And if we want to kill out either of these, we just hit Control C and it will stop that functioning.